Hi, welcome back to your favorite TV show. I'm your host, Mr. Allen, and this is Admiral Science. And today we're going to be talking about chemical and physical changes. Alright, so first off, start off with what we should know. Physical properties and properties that one can observe and measure. These are our physical properties. So when I say observation or observe, that means I want you to use your senses. That means I want to use your sight, your smell, your touch, your taste. Those are your senses I want you to use. And I want you to think about what you see, what you hear, what you smell, sometimes maybe what you taste. Alright, so those are observationals. Those are things that you use to describe an object. So if it's a physical property, you can describe it with those senses, or you can describe it by measuring it. Alright, when I say measurements, I want you to use numbers or use scales, 1 to 10, how dark or how light it is, the color. These are all types of scales. And if you can use a scale or a number, say a measurement, and those are also part of the physical properties. And here we have some common physical properties: viscosity, boiling point, freezing point, melting point, specific heat, malleable, ductile, color, hardness, odor, brittleness, texture, density, electrical conductivity. Those are just a few, and it is so many out there. So you can, as long as you can describe it with your observations or your measurements, it is a physical property. Now moving on to chemical properties. Chemical properties are those that describe a substance's ability to change into a new substance with different properties. Alright, so when you take a substance and you can change it to a different substance, those are chemical properties. So things that common chemical properties include reactivity, if it can react. Like iron reacts with oxygen, that forms rusting. If you see down at the bottom, rusting. Or like how baking soda reacts with vinegar. Those are all types of reactivity. Alright, flammability. Is it flammable or non-flammable? That is a type of chemical property. Whether it's acidic, whether it's basic. Those are types of chemical properties. Alright, just a few. A physical change is a change that affects one or more physical properties, such as when I painted my tables. Remember, my tables were all black and I painted them all different colors. That is a physical change. I changed the appearance of the tables. Taking wool from a sheep and making it into a sweater, that is a physical change. You're not changing the wool. The wool in your shirt is the same wool that came off the sheep. So wool is going to be wool no matter where it goes. You're just changing it from one location to another and turning it into a sweater. Alright, melting butter. When you melt butter, butter is still butter. It has not changed at all. Or ice melting. When ice melts, ice is still water. It's just a solid form of water. It melts into a liquid form of water. It is still water. And ice freezing, same thing. When you take a liquid form of ice and you freeze it, that is still water. It's just a solid form. That's ice freezing. So these are all examples of physical changes. You have not changed the product. The product is still the product. Alright? No matter what. When you start at point A and go to point B, it is still the same thing. When you start off with water as a liquid and you freeze it to a solid, it is still water. Alright, so let's know the difference between a physical change and a physical property. Physical change means that the change simply is describing the alteration of the object's appearance or alteration of its measurements, whereas a physical property simply describes the object or substance. So let's look at our broken pencil here. Alright, so let's give it some physical properties. Some physical properties of our broken pencil is that it is yellow. Alright, it has a black eraser tip. Alright, now the physical change is now that the one pencil is now broken in half, and now you can make two pencils. Alright, so the change describes the alteration, while the physical property describes the object. Alright, chemical change. Chemical changes are changes that occur when one or more substances change into an entirely new substance with different properties. Alright, so when wood burning, so when wood burns, it goes from this dense piece of wood into this carbon-based, charcoal-y type black substance. Alright, it's no longer wood no more. It's not wood. It is a new substance. Baking a cake, you go from this cake batter into this spongy, foamy type bread material. It is no longer the same object or same substance as it first started off with. So is Alka-Seltzer in water or an egg rotting. These are all examples of chemical changes. Some new product is being formed as a result of some chemical reaction. Alright, so some new product is being formed. This is all examples of chemical change. In physical change, nothing new forms. It is still the same at start to finish, but in chemical change, A and B is going to get you C. It is going to be something different. Alright, so chemical change versus chemical property. A chemical property describes a change that can or cannot happen. For example, flammability. Flammability simply says whether a substance can or cannot be cause a flame. Alright? So whether a shirt is flammable or non-flammable. That is a chemical property. But the chemical change is the shirt burning. Alright, now the shirt burning is a chemical change because a change is taking place. Alright, a chemical property simply says whether a change can or cannot happen. Whereas a chemical change says that the substance is going to something new. Alright, so let's now focus on chemical versus physical. Alright, our physical properties are easily reversible, so you can go back from one spot to another. Same with ice, you can melt ice and then refreeze it. No new products are formed. A is going to be A at the end, and often just a state change such as ice melting, butter melting, those type of things. It's simply just a physical appearance change. You painting a door, all right? It's simply a physical appearance change, all right? Whereas a chemical change is not easily reversible. If you burn wood, you cannot try to make it a new wood. You can't reverse the burned effect, all right? You can't scrape it off because the part you're scraping off is still burnt, all right? New products formed, exactly, and reactants are used up. And it often involves heat, light, sound, or some fizzing occurring. Alright? And electricity may be produced, a precipitate may form, and wood is going to burn. Alright? So, for example, wood is burning. Alright, so how to identify chemical changes? Alright, so there's certain ways. You can use by production of a gas, an odor of some sort, precipitate, and precipitate. See, what we see here is a colorless lead nitrate being mixed with a potassium iodide, forming lead iodide, which is the yellow substance right there. That's precipitate. It's formed by two liquids making a solid. That is an example of a chemical change because we're seeing two things happen here. Alright, we're seeing some color change and we're seeing a precipitate form. So that is an example of a chemical change. And like I said, it's done by observation, so you're going to use your observational skills. And any of these, preferably two, could indicate a chemical change. So let's see. All right, here we have a picture. Is this a chemical change or a physical change of this popsicle melting? Well, let's think about it. If we have a popsicle and it melts, does the popsicle change into a new substance if it melts? If you said no, you're correct. If it does not change into a new substance, it's a physical change because it's still the same juice that's on a popsicle being melted onto the ground, except for now it's from a solid form to a liquid form. So it is now a physical change. Is this a chemical or physical change? And the chemical change is that it is a piece of wood burning, and that is an example of a chemical change. Lead rusting is another example of a chemical change. Alright, it goes, the chemicals of the iron is reacting with the oxygen and is forming rust. And many people believe that, oh, water is the cause of rusting. No, rusting is going to happen automatically because of the oxygen in the air. But the reason why it may happen with water faster is, what is water? What makes up water? H2O. Alright, so because oxygen is in the water, it may speed up the reaction of rusting. And lastly, is this a chemical or physical change? Alright, so we have some clouds being formed out of a factory, and if we know that that's carbon dioxide inside those clouds, and that's a type of gas, and that gas being formed is an example that we can see that a chemical change is taking place. Alright, so if you have any questions, please review the video again. Go back to any points that you may not understand. Please be sure to know the difference between a chemical and a physical reaction and a chemical and physical properties. And please know the difference between each one. Alright? If you have any questions, please write them down in the comment section or refer to me in the morning. I will be here. Thank you for watching another edition of Admiral Science. I'm your host, Mr. Allen. I will see you next time.